Hello everyone, let's take a look. This is Dr. Lennon. Let's take a look at problem number 2 on the Chapter 15 assignment. So we've got a decision-making problem, and what we have is we have a chart with a bunch of choices for leasing an automobile for 3 years, 36 months. So we have a fixed monthly cost for each, we have a mileage allowance, and then we have a cost for each additional mile over the mileage allowance. So basically, we can develop formulas as below. So the formula for total cost is going to be $299 times 36,000, or X minus 36,000, where X is the number of miles driven, times 0.15 for the additional cost for the miles over 36,000. Down here it says what's the decision and what's the chance event. Well, you can go through each of them, but basically you can boil it down between 3 and 4. So the decision is selecting the best lease option. And then the chance of event is actually going to be the monthly cost, or the number of miles in 3. Well, the monthly cost does include something that's part of the decision. It includes the fixed cost of the monthly cost. So that's not a chance event completely. It has a part that is part of the decision. However, the miles driven is kind of completely up to chance in the sense that if that changes, you won't be able to control it. So number 3 should be the best option here, because number of miles is a better chance event than the monthly cost, because the monthly cost does have a completely predictable component, being the monthly cost. So we want to construct a payoff table for each one of these to kind of try and figure this out. So I've kind of captured all I've copied over the options for the monthly cost. So let's add let's do a mileage and then the payment for each of them and see how that goes. So the mileage, let's do mileage driven. And notice one thing that might trip you up if you tried this and got it wrong is it's the miles driven annually, but the lease is over a 3-year period. Over a 3-year period. So really, this should be 36,000, 45,000, and 54,000. So I'm going to put those in as the numbers: 36,000, 45,000, and 54,000. And then we have the formulas for each. So let's say, or maybe I've done this backwards compared to how it's laid out on the. Okay, so they've got it there. So let me switch it. So I'll put the mileages up here: 36,000, 45,000, and 54,000. And then here I'll put Honda, Midtown, and Hopkins. So the formula for each, if we want to compute, it's going to be the fixed cost times 30. So the monthly cost times 36 months. So 36 times $299 for this one. And then I need to add the mileage overage. So that's going to be the number of miles actually driven, which is above, minus the mileage allowance, which is 36,000, and then times the additional cost per mile, 0.15. Okay, so then I can drag that to the right. And then for the others, it's a little bit more complicated, right? Because at 36,000 miles, you're not above the mileage allowance, so that we don't actually need anything more complicated for the additional miles. So for this one, we can just put 310 times the 36, because she's not going to drive any additional miles. And same for Hopkins, actually, in the B13 and C13 cells. So we just got the 36 times the 325 for each of the first two. 36 times 325. And then we want to use the formulas to compute the others. So this is going to be 36 times 310 for Midtown, plus the additional mile cost, which is 0.2, times the miles driven, minus the 45,000, and then drag that over. Okay, got that one. Now we have one more left to do, so this is the 36 times the 325, plus the 0.15 times the miles driven minus the mileage allowance, 54,000. Okay, so that one's actually the same for all of them. Because 54,000 minus 54,000 is 0. So let's go back to the questions. Basically, these are the costs that we need to fill in. So how about I just copy over the first row to make sure we have it right. So 10, 7, 6, 4, 12, 1, 1, 4, 13, 4, 6, 4, 11, 6, 11, 160, 60, 12, 9, 60, 11, 700, all of these. So let's check that answer to make sure we got it right. Okay, so we got the table right. Now we want to do the optimistic, conservative, and minimax. So let's go back to the Excel and let's look at, suppose all cases are equally likely. Let's just compute the average cost. Average cost. So here we just do equals the sum of these three cells. So the sum of these divided by 3. And then copy that down for each of them. So what the conservative cost does is it just says, okay, the optimistic says, okay, best case scenario, what's the cheapest? So that's going to be Hopkins. So back over to Mine Tab, we want to select Hopkins for optimistic. So the conservative and the mini-max. So the conservative, you're concerned with the worst case scenario. So what's the worst case scenario in terms of payment? The worst case scenario here, we have consistent values, 11,700 for all of them. So although the average is lower for Midtown, you do have the one scenario where you pay 12,960. So the conservative approach should be Hopkins. Somehow I feel like I'm picking the wrong one, but let's see. I know the mini-max of, so conservative, let's say that's Hopkins. No, the optimistic I did wrong. It should be Honda. Because for optimistic, we're looking for the best case. So the optimistic, the cheapest you could pay if you don't drive a lot of miles is Honda at 10,764. So that should be Honda for the first one. And then the mini-max, what you need is you need a regret table. So, so let's see if we do a regret table. The regret is how much you would be losing in each of the scenarios. So you would have 3 regrets. So in essence, in the 36,000 mile case, the regret for Honda is 0 because it had the best. In the Midtown case, it's 10,000. The amount they paid. So this should be 11,160 minus 10,764. And then in the Hopkins case, it would be the 11,700 minus the 10,764. Okay, and then the same in each of the other cases. So the best possible price in the second scenario, 45,000 miles driven, in the life of the lease would be 12,114 minus the best case, which is the 11,160. And then 0 regret there because it's the smallest, and then 12,114 minus 11,700. Okay, and then the last decision for 54,000, we have the 13,464 minus the 11,700. We have the 12,960 minus the 11,700, and then we have a regret of 0 in this case. So let's compute the average regret. So the average regret, again, is just going to be the sum of those 3, and then we'll divide it by 3. Okay, so 906, and then 450. So we see Hopkins has the lowest regret. I believe that's how this one, for some reason I'm thinking maybe this is incorrect. Let's see, let's double check it. Okay, so let's go ahead and put Hopkins in here and see what happens. Somehow I think one of these isn't quite correct, but let's go ahead and check it. Oh no, we got them all right. So the average regret method was correct. Okay, so now it says suppose the probabilities are different. Let's look at the expected value approach, 0.5, 0.4, and 0.1. So the 0.5, 0.4, and 0.1, that's all we're going to do is the expected value. We're just weighting each of the options. So we have 0.5 times, for each one of the categories. So let's do the expected value amount over here. Expected value. And we have the weight. So we have 0.5 times the possibility that she'll drive the 36,000 miles plus 0.4 times the probability that she'll drive the cost of 45,000, and then plus 0.1 times the cost of the 54,000. Right, it's the weighted mean, and then we'll fill that down for the other two. So we see the expected value approach is the best for Midtown. So this one should be Midtown. And then the next part where it asks is develop a risk profile for the decision and what's the most likely cost. So the most likely, we're looking at the Midtown case that we selected. The most likely is a payment of $11,160, and that is the case for the 0.5 probability and the 0.4 probability. So the risk profile there is 0.9 for the probability, and what did we say? 11,160. So let's check the work on this. So we got it all set. And then the last one is just a risk profile with different probabilities, 0.3, 0.4, and 0.3. So I'll leave that one to you. So hopefully this helps on the decision making and expected value approaches.